Let's do a few examples of this. So I want to do a few examples of counting permutations and combinations. Of course, we did the book example before when we talked about combinations and permutations to begin with. And here, what we're going to do is we're going to talk about how many 7-card hands are possible from a standard deck of cards. So the idea is that you have 52 cards, and you don't care about the order that the cards are put in your hand. You just care about what's the final set of 7 cards. And so altogether, there's going to be 52 choose 7 cards possible. So that's going to be the number of 7-card hands you can have when you play with a standard deck. Now, let's count the number of 5-card hands that contain the 9 of hearts. And I want to think about this in a slightly different way than we had before. So since we're talking about hands of cards, we're talking about combinations because we don't care about the order that the cards are arranged. We just care about what's the final set of cards that we have. Okay, so this is, I need to be very careful about using the words choose and arrange and things, but we're choosing 5 cards from 52. And so the question here is, how many ways are there to choose 5 cards from the 52 if we want one of those cards to be the 9 of hearts? So the way that I'm going to do this is I'm going to pretend that we have a deck of cards in our hand, and I'm going to take the 9 of hearts out of the deck of cards, and I'm going to make it its own pile. Okay, so I'm going to put the 9 of hearts in one pile, the 51 other cards in the other pile. Of that one 9 of heart pile, I'm going to choose one of them. So of that one card, I'm going to choose it. Of the 51 remaining cards, I'm going to choose 4 of them. One choose one is just one. So if you think about just intuitively what that means, this is the number of ways. If you have one object, how many ways are there to choose that one object? Well, you just choose it. There's just one way to do it. So this turns out to be 51 choose 4, because 1 choose 1 is just 1. Now, how many 5-card hands contain exactly 1 heart? The way to do this is the same as before. Take the hearts out of the deck of cards. You have a pile of hearts and you have a pile of non-hearts. There's 13 hearts. There's 39 non-hearts. Of the 13 hearts, you're going to choose exactly one of them to go in your hand. And of the 39 non-hearts, you're going to choose 4 of them to go in your hand. And so whatever this number works out to, that's going to be the number of 5-card hands that contain exactly 1 heart. Now, how many contain at least 1 heart? This is a little bit different, and there's 2 ways that you can count this. What you can do is you can think about what's the total number of 5-card hands that you have, and then you're going to subtract the number of hands that don't have any hearts, because what you'll be left with will be the ones that have at least 1 heart. So how many have exactly no hearts? Well, of the 13, you're going to choose 0, and of the 39 non-hearts, you're going to choose 5. So that's one way to do this, and you'll end up with the right number if you compute what that is. Another way to do this is to think about at least 1 heart, meaning exactly 1, or exactly 2, or exactly 3, or exactly 4, or exactly 5. And since there's no overlap, you can just add up each of these numbers. So you would end up with 13 choose 1 times 39 choose 4. That's the number of ways to get exactly 1 heart. And then plus 13 choose 2 times 39 choose 3. That's the number of ways to get exactly 2 hearts. The number of ways to get exactly 3 hearts is 13 choose 3 times 39 choose 2. The number of ways to get exactly 4 hearts is 13 choose 4 times 39 choose 1. And the number of ways to get exactly 5 hearts is 13 choose 5. And then of the 39 non-hearts, you choose 0 of them. Okay, so 39 choose 0. So it turns out either way you want to do this, clearly the first way is better from a computational perspective, but either of these ways will give you the right answer. Okay, so this is 2 different ways of counting the same thing. We're going to do this a lot. We're going to have 2 different ways of counting the same thing. And so we'll have these kind of combination ideas. I'm trying to move this over just a little bit so that we can read it a little better. But we'll have these kind of combination arguments. So we'll have these 2 different ways of counting the same thing. Okay, so that's the number of ways that you can have at least 1 heart in a 5-card hand. Now, how many ways are there to get exactly 2 hearts and 2 diamonds? the way that I would think about this problem would be very similar to the previous ones. Let's take the standard deck of 52 cards. I'm going to take out the hearts and put them in one pile. I'm going to take out the diamonds and put them in another pile. And then we're going to take the non-hearts and non-diamonds and put them in a third pile. And of the 13 hearts, we want to choose exactly 2 of them. Of the 13 diamonds, we want to choose exactly 2 of them. Of the 26 non-hearts and non-diamonds, we want to choose exactly 1, because we have a 5-card hand. Notice that each of these numbers up top have added up to 52, and down below have added up to 5. Okay, so likewise, the top numbers add up to 52, the bottom numbers add up to 5. So this is the way that you can get exactly 2 hearts and 2 diamonds in a 5-card hand. And then finally, how many ways are there to get a 5-card hand that contains all cards of the same suit? So this is called a flush. So if you want all cards of the same, it's actually not quite called a flush because I'm including the royal flushes and the straight flushes, but I want to count how many ways are there to get all cards of the same suit. And so what that means is how many ways are there to get exactly 5 clubs? Well, of the 13 clubs, you choose 5. Of the 39 clubs, you choose none. How many ways are there to get exactly 5 diamonds? What's the same number? 13 choose 5 times 39 choose 0. The number of ways to get exactly 5 hearts is 13 choose 5 times 39 choose 0. And finally, the number of ways to get exactly 5 spades is 13 choose 5 times 39 choose 0. That's one way that you can count, and that's fine. I think another way that you can count is to think about a specific instance here. How many ways are there to get exactly 5, say, clubs? Just pick one, pick a suit. So the number of ways to get exactly 5 clubs is going to be 13 choose 5 times 39 choose 0. Now, instead of just thinking about and adding all the rest of the cases, another thing that you could do is think about, since all these numbers are the same regardless of the suit, how many different cases are there? How many different suits are there? And so what you would do is you would multiply by 4. Okay, so that's another way that you can get that same count in there. Okay, so that's the number of ways that you can have all cards of the same suit.